Hello everyone, my name is Abdullah Hannan and this is the presentation for EE415 Analog CMOS Integrated Circuits course project. Our project was to design an 8-bit digital to analog converter. The digital to analog converter comprised of two parts. The first one was an R2 bar ladder in voltage mode with reference voltage of 4 volts, and the second one was an op amp, which was used in unity gain configuration. The digital to analog converter had some specifications which were supposed to be met. One of them was that the phase margin should be at least 50 degrees, the output impedance should be less than 3 ohms at 1 kilohertz, and that the total current of the digital to analog converter should be less than 10 milliamps. So here is the topology of my op-amp. The op-amp was basically a three-stage amplifier. As we can see, this is the first stage over here, this is the second stage, and this is the third stage. Um, we also have a feedback RC circuit, which is used for stability. These are the dimensions of the transistors which were used and the values of the resistors and the capacitances. As we can see that we were using a 28 picofarad capacitance, which is relatively high, and we will see it in the layout that it occupies a large area in the layout as well. So this is the layout for the op amp. As I said previously, this is the capacitor occupying a lot of space. These are the resistors, and the rest of them are the transistors used. The resistors which are used were R poly H because the resistance values were great. This one was about 90 kilo ohms and this one was about 35 kilo ohms. So R poly H has a high resistance per square. So I used R poly H, and I used tunnel capacitance because it also has high capacitance per unit area. Then I performed the DRC and the LVS checks. The DRC checks was done with negligible errors, and the LVS check was done with no mismatches between the layout and the schematic. And then finally, the parasitic resistors were extracted. This is a topology for the R2 bar ladder. The resistors used were her of 100 mega ohms, and the transistors were used as switches. PMOS was used to switch for VREF, and the NMOS was used to ground or short the branch. The sizes of the PMOS is 1.6 micrometer, and the sizes of the NMOS is 0.8 micrometers. So this is the layout of the R2 bar ladder. Since the resistance values used were really high, this is why the area of the R2 bar ladder is also large. It is about 24 millimeters square resistors. Similar to the op amp, I did the DRC checks with negligible errors and the LVS check showing no mismatches between the layout, and finally the resistance of the parasitic resistances of the R2 bar ladder were extracted. Now I will show you some of the results of my simulations. This is the symbol of the op amp, and this is a plot of the gain against the input voltages. As you can see, for even 0 input voltage and 4 input voltage, the two extreme values, the gain is more than 50 dB. The peak of the gain occurs at around 2 volts and it is more than 85 dB. The stability analysis shows that the phase margin was 59 dB, which is greater than the specification requirement, which was 50 dB. This plot over here shows the linearity of the op amp. As you can see that as the input goes to 0, the output of the op amp also goes to 0. To be exact, it goes to 0.24 millivolts, and when the input is 4 volts, the output goes as high as 3.998 volts. So this shows that the digital to analog converter is indeed linear. Here is a plot of the output impedance against the input voltages as the input voltage is swept from 0 to 4 volts. Again, we can see that the output impedance reaches a maximum value of about 2.75 ohms, which is less than 3 ohms. That was the requirement of this design. And finally, this is the plot for total current of the digital to analog converter as all of the combinations are changed and visited. As you can see that the total current remains less than or is limited by 10 milliamps for the whole design. So this confirms that, so this also fulfills the requirement of 10 milliamps total current.